Yeah. So, probability. Today's lesson is about sample space and basic probability. This is just kind of like the intro to probability. So we have some vocabulary for you. Sample space is the set of all possible outcomes. So the sample space, and you denote it by these little curvy parentheses, these are brackets, like that denotes a set. And so when you're talking about the sample set, that's going to be all the possible outcomes for that event. An intersection of two sets are the elements that are in both A and B. So the word and is going to mean intersection. And we denote intersection with a symbol like that. The union of two sets, so if it's asking you for the union of two sets of events, it means the elements that are in A or B, and we denote union with a U, just a curved U. So the difference between intersection and union is and or. And or. Still two sets, or even more than two sets, two or more sets, and the elements that are either in A and B, or the union is A or B. The complement. The complement of a set are the elements that are not in the set. So for example, if we had a deck of cards and I said hearts, so the complement would be not hearts, would be clubs, spades, and diamonds. So the complement is everything that's not in the set. And we denote it by, if the set is A, we denote it by AC or BC. So A complement or B complement. And then the odds. Maybe you've heard about teams or people having odds. So the odds of an event is the ratio of favorable to unfavorable. Not favorable to total, kind of like probability is. Probability is the ratio of favorable outcomes to total. But odds is favorable to unfavorable. And when you're taking the probability, you're going to see a capital P with some parentheses, and that's going to tell you the probability of the event. So for this example, it would be the probability of event A, whatever event A is. This is the probability of A and B, so this would be the intersection, A and B, see? The probability of A or B, so this would be the union. What's the probability of A or B happening? And this one is the probability of A complement. And so we're going to talk a little bit about complement, but probability of A complement have a relationship. Alright, so it's just some examples. List the sample space. So we are going to just list the sample space for these events. So for tossing a coin, the sample space would be the set of heads or tails. Alright, because that is the sample space. You can either have a head or a tail. If you're rolling a die, the sample space is going to be, the possible outcomes of rolling that six-sided number cube, a die. Sometimes you'll see it say die, sometimes you'll see it say six-sided number cube. Now, drawing a marble, if you have 2 red, 3 blue, and 1 white. So if you have these marbles in a bag, the sample space would be 2 red, 3 blue, and 1 white. That would be the sample space, no markers running out, of those events. Alright, so example 2. Given the sets, find A intersection B and A union B. Alright, so we have set A and we have a set B. This is a 1. And you see I've put it in a Venn diagram. You'll see several Venn diagrams when you're going through probability and looking at sets and sample space. And it's just a way to organize the data. The overlapping circle is what the two sets have in common. And then what they don't share, you'll see on their respective sides. So use the Venn diagram to answer the questions. Here we go. So these are the factors of 12. In A, the factors of 12. So we have 1, 2, 3, 4, 6, and 12. Those are all the factors of 12. Over here in set B, we have the factors of 16. 1, 2, 4, 8, and 16. What they have in common right here, 1, 2, and 4, is to us the intersection. The union is either in A or B. So the union would be all of these. So here we go. What is set A? So set A is 1, 2, 3, 4, 6, and 12. Set B, like we just said, is 1, 2, 4, 8, and 16. What is the intersection of A and B? So the intersection is this set 1, 2, and 4. It's what they both have in common right here? So that's the intersection. Whoops, nope. The intersection. What is A union B? That would be everything together. And I'm going to do it in order from least to greatest because it's just mathematicians like it better. So the set 1, 2, 3, 4, 6, 8, 12, and 16. So the union is everything in the Venn diagram. Okay? Okay, so in a class of 60, 21 sign up for chorus, 29 sign up for band, and 5 take both. 15 students take neither. So we need to fill in our Venn diagram. I have set A is chorus, set B is band. And we first want to talk about 5 take both. So 5 students take both. Now, it says that we have 60 total, so we know that at the end we want to make sure our total is 60. 21 sign up for chorus. I can't put a 21 here because I've already counted 5 in the intersection. So 21 take away 5 is 16. So that means 16 are over here in just chorus. 29 signed up for band, but remember 5 are already right here, so I need to do 29 minus 5, and that is 24. So that means my set A, chorus, is 21. My set band is 29, and then I have 5 in the intersection. Now, 15 take neither. So if 15 take neither, then we need to put a 15 out here to represent part of the students, but 15 take neither. We can't put it in the circles because they don't take band or chorus. And then we want to just double check and make sure all of our numbers add up to 60. So we're going to add up 16 plus 5 plus 24. I think we would get, let's see, 21 plus 29. No. 16, 5, and 24. So that is 10, 15, 45 plus this 15. And so that is 60. So we're good. We got our numbers in the right spot. Chorus, band, intersection, neither. So what is the intersection of A and B? So the intersection is 5 students, right? 5 students. The union of A and B would be all of this right here, which we just added up would be 45 students. Okay? Now, complement. Complement means it's not in this set. So depending on what set we're talking about, the complement can be a little bit different. So if we're talking about a complement, we're talking about how many total, so I'm just going to put a box around here so you can see what I'm talking about. How many of these students are not in set A? So set A right here has 21 students. And we know that there are 60 students total. So 60 minus 21 is 39, I think. So that would be the people in A complement, the people who are not in set A. So set A has 21, so that means 39 people are not in set A. B complement, there are 29 people in B complement, so that means there are 31 people, there are 29 people in B, so that means there would be 31 people in B complement. So it's basically everybody else not in B. Now, this one is a little tricky. This is A intersection B complement. A intersection B complement. So we have to look at who is not in A intersection B. A intersection B we know is 5 people. So 60 minus 5 is 55. So there are 55 people who are not in A intersection B. And then A union B complement. So we take all of this, A union B. Why did I say 15? It's supposed to be 45. No, yeah, 45. Sorry. Did I say 15 or did I say 45? Okay, so 45. So there are 45 people in A union B. That means 45 students in this class take either band, chorus, or both. So A union B complement would be 60 minus 45, or this 15 that takes neither. That would be A union B complement. And then a little note about complement probability. To find the probability of some complement, you subtract it from 100% or 1. 100% and 1 is the same thing. So for our example, 100% represents 60 students. So that's why I was subtracting from 60 to get my complement. So just remember that. Set A and A complement. So A, probability of A, and probability of A complement is going to equal 100%, or it's going to equal 1.0. So that's just important for you to know. Alright, so some basic probability. Here we go. You're tossing 3 coins. Now this stuff I'm going to move fast because I expect that you know it. You're going to list the sample space. So for the 3 coins, you have the probability of 3 heads, head, 2 tails, head, tail, head, and heads, heads, tail. Then you have the probability to get all of the exact opposites. And so your sample space is 8 different choices, 8 different items, because there's 3 coins. And you could just do 2 times 2 times 2, because each coin has 2 possible outcomes. So 2 times 2 times 2. The probability of all heads, you can see right here there's 1/8 all heads. The probability of 2 tails. So if you are finding the probability of 2 tails, you can see we have 2 tails here and 2 tails here. And then 2 tails here. So 1, 2, 3. So 3/8. The probability of the no heads. So the only one up here that has no heads would be tails, 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 and that would be 1/8. And then the probability of at least 1 tail. So we have at least 1 tail. Well, the only one up here that doesn't have any tails is heads, heads, heads. So it would be 7/8, because only one doesn't have at least 1 tail in it. The probability of no tails, the complement. So got to think about this. The probability of having no tails would just be this one right here. But then the complement of that one would be all the rest. So the probability of not having a tail, the complement of that would be 7/8. Because having not a tail is 1/8. So the complement would be all of the rest, having at least 1 tail, 2 tails, or 3 tails. In a card probability of a heart. So there's 4 suits, so that would be 1/4. If you want to think about it, it'd be 13/52. Probability of black would be half of the deck, because you have spades and you have clubs. Probability of a 2 or a jack. So the probability of a 2 is 4/52. And the probability of a jack is 4/52. And because it says or, you're going to add them. So we're going to get 8/52, which is, I think, 2/13. And then the probability of a heart complement. So the probability of a heart, we already said, was 1/4. So the probability of a complement would be 3/4, because remember, you just subtract it from 1. Alright, so odds. Going to move through this quickly. Odds is the ratio of favorable to unfavorable. So let's say there's a 75% chance of rain on Sunday. That means, 75% means that 75 out of 100 days, like today, it normally rains. 75 out of 100, because it's percent. Now the reason I need to know that 100 is because it tells me the unfavorable outcomes. So the favorable are 75, the unfavorable are 25, because 75 rain, 25 do not, to equal 100. The odds, therefore, are 75 to 25, which is 3 to 1. And that's how you would say it, 3 to 1. So if you hear the odds of a horse in a race, or 5 to 2, that means 5 yes and 2 no. So you try. What are the odds of drawing an ace at random from a deck? What are the odds of drawing an ace at random? So you try that one, and then I'll go over it. So the favorable aces, there are 4 aces out of 52 cards. So there's 52 cards in a deck. But the favorable are 4, and the unfavorable are 48, which means you have the odds of drawing an ace are 1/12, or 1 to 12. So that would be the odds of drawing an ace, 1 to 12. Okay, we'll practice more.